Hello everyone, I'm Ashish Ranjan, an educator on Unacademy. You can follow me on the Unacademy Learning app where you will find my other courses as well. This lesson is about horizontal alignment and particularly we will have a look at extra widening of roads. So do not forget to rate, review and share my video and also subscribe to the YouTube channel of Unacademy. So let us begin. So we will now have a look at the design of extra widening. So we will have a look at IRC approach, and in that we will particularly look into the mechanical widening. And why do we provide the mechanical widening? That is due to the off-tracking that is occurring due to the rigidity of the wheelbase. So you can see this is a sample vehicle and this entire length is given as 194. This 194 I'm sorry. Yeah, so this 194 is in inches. So this length is 34.9, this starting to the first front wheels, and the gap between the front wheels to the rear wheels is 117.5, and the gap from the rear wheels to the end is 41.6. So as you can see, so as I told you in the previous video that these front wheels, they actually turn with the steering, but the rear wheels, they don't turn actually, they follow the straight path. So that actually leads to the off tracking, and that is basically due to the rigidity of the wheelbase. So now psychological widening. So why is psychological widening? So there is greater maneuverability of steering at higher speeds, also extra space requirement for the overhangs of vehicles, and also greater clearance for crossing and overtaking vehicles on curves. So basically these are the reasons why psychological widening is also provided. So you have two types of widening. The first one is mechanical widening, second one is psychological widening. Now let us have a look at the formulation for the mechanical widening. So as you can see over here, this is the center, and you have this is the starting of the road, this is the end of the road, and you have this extra widening as WM. So this extra widening is WM, this entire central portion is the middle road or the road, and this is the right portion of the road. So as you can see over here, there is some thickness, let us say T. So this thickness is a bit more than this thickness, and the radius to this point is R1, that is to the start of this curve, and R2 is basically to the end of this curve. So you can see that WM, that is this width, is equal to R2 minus R1. And now if you take the triangle OAB, this triangle if you take, so you can see that OB is a hypotenuse, so OB square is equal to OA square plus AB square. Therefore OA square, this OA square is equal to OB square minus BA square, and OA is basically this R1 square, and this OA is actually R1, this curve, the inner curve, and OB is actually the outer curve, that is R2 square, and BA, and this BA, this thing is actually the length of the vehicle. Okay, so R1 square is equal to R2 square minus L square. Now what you can do is that instead of R1 you can write R1 is equal to R2 minus WM. So you get R2 minus WM whole square is equal to R2 square minus L square, and if you rearrange you will get L square is equal to WM into 2R2 minus WM. Okay, and again if you can rearrange you will get WM is equal to L square divided by 2R2 minus WM, and now you know that WM is pretty less in comparison to R2, so basically you ignore WM and R2, this R2 you actually take it as R, that is the center point. Okay, so this is an approximation that 2R2 minus WM is approximated to 2 into R. So you get the final equation as WM is equal to L square divided by 2 into R approximately, where R is the mean radius of the curve, that is R1 plus R2 divided by 2. And if you can, let me go back. So WM is equal to L square by 2R. Now if you generalize this, you can have WM is equal to N into L square by 2R, where N is the number of lanes of the road, R is the mean radius of the curve, and small l, that is the length of wheelbase of the longest vehicle. And if you go by the suggestions that we have been, or the specifications that have been given to us by the IRC, so L is actually 6 meters or 6.1 meters for commercial vehicles. So now let us move on to the psychological widening. We had a look at the mechanical widening. Now we will have a look at the psychological widening. So as for the psychological widening, there is nothing as such the formulas that we can derive. So we are going by the empirical formula. So this formula we have, that is WPS is equal to V by 9.5 root under of R, where V is the design speed of the vehicle in kilometer per hour, this V, and this R. R is the radius of the curve in meters. And you get this WPS, that is the widening that we have to provide due to psychological reasons. So now the total extra widening. What is the total extra widening? Total extra widening is the summation of the mechanical widening and the psychological widening. And basically you get WE, that is the total widening, is equal to WM due to mechanical plus WPS due to psychological, is equal to, now what is WM? This is WM, NL square by 2R. So NL square by 2R plus WPS is V by 9.5 root R. V by 9.5 root R. So WE, that is total extra widening, is equal to NL square by 2R plus V by 9.5 root R. So what are the variables in this? N, that is number of lanes. L, that is the length of the vehicle, length of the wheelbase of the longest vehicle, and the design speed, and also R, that is the radius of the curve, that is mean radius. So these are the unknowns that we need to be set, and upon that we can find out the total extra widening that needs to be provided so as to maintain the safety and provide comfort level to the drivers. Now, extra widening, as I told you, it is a function of number of lanes and radius of the curve. So over here you can see there is a small table in which there is a radius of curve, and over here you have a 2-lane or a single lane, basically the number of lanes. And if the radius of curve is up to 20 meters, in that case for the 2 lanes you have this extra widening of approx 1.5 meters, and in case of single lane you have an extra widening of approximately 0.9 meters. And if the radius of curve increases, so similarly for the 2 lane this approximately decreases. See, because if the radius of curve is more, that is the road width is actually high from before by itself only. In that case you do not need to provide much of a widening, and you can go by the formula also. You can see if this radius is more, the widening will be less. So if you go in this way, this manner, the widening will decrease. Okay. And similarly for the single lane also, if you move towards right, that is if the radius of curve increases, the extra widening decreases. And if the radius of curve is above 300 meters, in that case you hardly provide any extra widening. In that case you do not need to provide any such widening. Okay. And also you can see that if you move downward, the extra widening decreases. This is because for 2 lane n is equal to 2, for single lane n is equal to 1, and total widening is directly proportional to n. Therefore, as we move downward in this table, the extra widening decreases. Now, single lane roads. Only mechanical widening is sufficient, as during crossing maneuvers, outer wheels of vehicles have to use the shoulders, whether on the straight or on the curve. Okay. So if you can recall, we had learned about shoulders. So they were actually provided on the sides of the roads to support the main road or the pavement. So if there are single lane roads, in that case only mechanical widening is sufficient. Okay. And if there are multi-lane roads, in that case the pavement widening may be calculated by adding half the widening for 2-lane roads for each lane. Okay. So you will add half of the widening for 2-lane roads for each lane. Okay. So that is what we will add for the multi-lane roads. So that's all that we have from this lesson. In case you have any doubts regarding any of the topics, feel free to contact me on the Unacademy platform, or you can even comment it out on the video, and I would get back to you as soon as I can. And also do not forget to rate, review and share my video, and also subscribe to the YouTube channel of Unacademy. Thank you.